In this video, we'll see how isolated containers using Rafay's admission control for Kata work. In the last video, we saw how Rafay GPU PaaS achieves and implements multi-tenancy in a secure manner to avoid things like container escapes in a multi-tenant environment. But let's look at a demonstration of this in action. Let's look at how the Rafay admission controller works for Kata containers. Let's go look at our cluster here. And let's open this in full screen so we can see the whole thing. This is deployed. So let's go to Cube System. And if you notice here, we have the Kata deploy resources running here, right? So this has been deployed here. But one of the challenges users have with Kata containers is you got to attach the right label as a user, and it's almost impossible to expect users to specify the right labels and all of that, at least in a multi-tenant environment. So how do we automate the injection of the Kata labels when the user attempts to deploy an application? To do this, Rafay has an admission controller, and that, let's just go look at it. And that gets deployed in Rafay system. And if you look at this thing called patch pod runtime class, this is the admission controller, and it is looking for new APIs that are scheduled or attempted to be scheduled by the API server, and will automatically inject the Kata runtime class to them if needed. Now, now let's go look at the node in our cluster here. This is a cluster where we had deployed the Kata runtime. And if you go look at the kernel, the Linux kernel is operating here. It's 6.5, just pay attention to this, 6501025 GCP. Okay, we'll go deploy to two namespaces, test1 and test2. And if you go look at, let's go describe the namespace, kubectl describe namespace test1. And if you notice this, there's a runtime class called Kata Kimu. So anything deployed here will automatically operate as a Kata container. On a similar note here, if you notice this does not have the same runtime class label. So anything deployed here will automatically be deployed as a regular pod with a regular runtime. Nginx YAML pod spec. It just goes and deploys an Nginx pod. So what I'll do now is I'll say kubectl apply -f nginx.yaml, but I want to go deploy this in the test1 namespace. Okay, our pod's being created. Let's go check on it actually. kubectl get po -n test1. And if you notice this, our pod's running. It kind of came up pretty quickly. But we'll check in a couple of minutes what version of the Linux kernel it's running under. So let's go check that. To do that, -a. If you notice that, it's running 6.1.62, right? It's kind of different from what we saw here, right? So if you notice here, we had 6.5, and here it's running Linux 6.1. So it's effectively running in a micro VM. But let's do the same thing here. kubectl apply -f nginx.yaml -n test2. Test2 was the one that where we did not have the Kata runtime. Now, if I go and attempt this, notice that this is identical to what we saw here on the node. So I think the point we're trying to make is the Kata runtime is deploying a different, the pods getting deployed in a essentially a micro VM versus the other one where, in theory, if this pod was bad and it attempted a container escape, anything in test two could potentially jump out. The one in test one cannot, right? Because Kata is running it as an isolated container. To demonstrate this further, let's attempt to do a container escape. So what we're going to do here is we're going to exec into our Nginx pod running in the test1 namespace, and we're going to run this bash command, which is going to effectively list everything in our C group. Let's look at that. And if I do this, and we notice it's listing a bunch of things which now let's compare and contrast that with the other one in a second. Let's go do that side by side. So I'm going to copy the same thing. And if you notice, the only difference between the commands is this is running in test2 and this is running in test1. So let's go attempt that. And as you can see here, this one it looks very different. This is essentially listing out everything in the host C group. It's the container running in the pod inside the test2 namespace. As you can see, has access to the host nodes. In theory, I could possibly jump out, escape out, and do some nasty things. Versus the stuff on the left here, and you can see it looks completely different from the stuff on the right. These two don't look the same at all. And this is because the pod deployed on the left is running in a micro VM. Now, the point I want to make out here is if you go to the pod spec, there is nothing the user had to do. The user did not have to change a thing in their pod spec. They bring their regular pod spec, and the Rafay admission controller automatically injects the necessary things into the pod spec. Then it's scheduled and ensures that it runs as a Kata container. So just to be 100% sure, and if you go look at this and you scroll all the way to the top, and if you notice, everything deployed here will automatically have the Kata Kimu runtime class attached to it. But the user had absolutely nothing to do. Their spec remained the same. Rafay automatically injected everything.